Little X and Y. Oh, whatever. Whatever, right? And what do we do? Put your phone away. Unless you're getting out of my Google Sheets, and in which case that'd be swell, but you're not. I can tell. You know how I can tell? Because you're like, oh my, like this. Nobody does that with Google Sheet. Nobody. Maybe me, but not on my phone. I might get excited about a spreadsheet, but not on my phone. Okay? You can always tell. Turn it off, woman. Put it away. Don't even tell me. Just shush. Thank you. So last week we did some of this. Oh, let's make a scatter plot. What? And some of us did it on Desmos. Some of us did it on our the TI-A3s, A9s, A4s, whatever. I don't care how you get here. Just freaking get here. Okay? That's number one. I want to see this on every single stinking problem you do. You should always check this. Scream. It looks kind of linear. Yeah, I would agree with you. That's good. What if I did it? Are you singing? Choir's that way. Go away. If the data looked like this, and it kind of had this little curvy-wurvy look to it, that's not linear. That's dumb. Don't try to fit a line to that. That's dumb. Okay? There's other classes for that. That's not the point of this class. We're pretty much everything we're going to look at is linear. Okay? Now, once we've done that, we also talked about how do we find R. And we all found it last week. It was very straightforward. It's very easy to do. Okay? So in your particular situation, we're going to hit it again today. Just make sure you remember it. Now, here's the deal. Today's lesson is how do we test the correlation to see if it's significant. That's the whole point of today's lesson, friends. If it is significant, then we're going to keep going with this procedure. If it's not, we're done. It's not good correlation. Good, then why are you predicting things? Stop, back away. It's a dumb idea. Huh? It's true. How do you do it? Well, I'm glad you asked. The test will always be thusly. Rho equals 0. Rho not equals 0. What's rho, Mr. Groom? I'm glad you asked. Rho is the correlation of the population. And just like with mu, nobody knows mu, so we deal with x bar. Well, nobody knows rho, so we deal with r. Nice. What kind of test is it, Mr. Grimm? I'm glad you asked. It's a t-test. And we will always use 0.05 for this, but of course the guy could, or a lady, or whoever. Whatever, whoever you are, you could also use alphas 0.01 or 0.1 or any other points that we've ever used in this class. It's not like it's something special about 0.05, but we will try to keep it, kind of easy to work with. Now I will tell you what page it's on so that a person can reference it, because it's pretty straightforward. But you're like, I want to see it again. Okay, it's fine. It is on, for crying out loud, where is it? You would think I could find it. Nope, I found it. There it is, I found it. I knew I would. It is T is equal to R times the square root of n minus 2 over 1 minus r squared. That is how you find your T. Now, Abby, how many degrees of freedom would we need to have here? It's a good question, isn't it?
Yeah, I don't know.
I'm going to tell you, it's n minus 2. Oh my gosh, it's like literally right there. You're right. It is. Good job, Abs.
So it's 1 minus r squared?
1 minus r squared. That is correct.
It's fine if that comes out like super negative.
Ooh. R, listen, R.
Jesus Lord.
Listen, R is always between here and here, yes? Right? And really, let's be honest, it's always between here and here. Let's lose the negatives, or the ones, all right? Does that make sense? If you lose the ones on either end, that means it's a decimal. What happens when you square a decimal? It's a decimal. That means this denominator will always be positive. The only time we could run into an issue is if it was 1, but if r squared's 1, why are you testing to see if it's significant? Of course it's significant. Okay? Of course. Listen, the only way that r squared is going to equal 1 is if r is either plus or minus 1. If r is plus or minus 1, it's perfectly linear. Of course it's significant. There's no reason to test that. It's only a situation like this. You're like, Mr. Groom, I feel like I got r is equal to 0.79. Is that significant or not? I don't know. Let's find out. Okay. I don't know. We'll find out. Notice, by the way, what happens as r gets larger? This is, notice, 0.81, for instance. You see this? Right? Mr. Groom sucks at math, so I'm going to go 0.8. Are you with me on this? Oh, 0.64. What? Now look what happens when you do 1 minus r squared. What do you get? Well, you get 0.19 and you get 36 or something. Notice, this is a smaller number, correct? In the denominator. Oh boy, what's that going to do to our number as a whole? Make it bigger. And if it makes it bigger, it's going to force it where? Out to the tails. And when it gets out to the tails, it's going to be out in the tails, which means it's going to be significanter. Yes? And there will be a value of r where it'll be not quite or right on the borderline. Yes? And so, of course, that's how we'll do it. Okay. Now, this is just a straight up good old-fashioned t-test. I mean, this hypothetically, this was 2.02 and 2.02. Just hypothetically, I did make those numbers up, but suppose it were. And you did this little deal and you got negative 2.3. Is it significant? Yes. Yes, it is. Mr. Grimm, could we do a p-value for that? We could. Review with me, if you would. How would we do that? Just think about this for a minute. On the TI calculators, how do we do it? TCDF, that's correct. From negative infinity to negative whatever I said. What did I say, 2.36 or something? 2.3, well, abs. And then like n minus 2 degrees of freedom, right? Are you with me on that? Does that make sense? Now, what's n minus 2? I haven't told you yet, just chillax. Now, suppose that came out to be like 0.01 or something. Is that your p-value? No, because you need to do what? Times it by 2. Why? Because it's a two-tailed test. Yes? Likewise on the giggle sheets, would it be t dot dis, what have you, so forth. Mr. Grimm, what if it was positive 2.3? Well, people on the calculators, you guys would switch these around and, of course, make that positive E99, obviously, yes? On the Google Sheets, it would be, you'd have to do 1 minus your t dot dis, yes? And then times that by 2. So, in other words, that didn't change at all. It's just a t distribution. That's all it is. Okay? All right, let's try one, shall we? Now, today we're going to collect one of my favorite pieces of data. And I'm not sure, I may have asked this question before at some point, because I kind of want to say I've heard this, we've discussed it a little bit before about one other thing, but we've never done regression with this. And so I want to show you something here just kind of for fun. So what you're going to do is your age. Now, keep this in mind, by the way. Keep this in mind. When we put these numbers in, we're saying that we would like to predict a person who's, like, say, 17 or 18 years old. I'd like to predict your mom's age. Okay? A generic 17-year-old. Now, if your mother had you at age 12, that obviously you're a weirdo. That stands out. If your mom had you at age 62, that's also a little strange. Okay? But your generic average woman giving birth is in that, that range, obviously, whether you're a firstborn or a later arrival and what have you. But that mid to late 20s routine. So in a few minutes when we get this, when we get a y equals mx plus b, if we get a plus b of something like, 26, would that shock anybody? No. Because some of us are firstborn, some of us are later borns. Some of us, our mommies wait a little longer, they may have babies and what have you. Whatever. By the way, for everyone who waited till they were 39 to have a kid, there's someone on the other end that got started at 14. Okay? Now, in every class? No! I've done this every year for I don't know how many years. There always is some weird class. One year, well, you'll see in a few minutes. But one year I had where all the young kids had really old moms. And all the old kids in the class had really young moms. That's weird. That's weird. To the point where the slope was actually negative. I know. It's weird. Okay, go ahead. We'll start here, Kaylee. Yes, Miss Wagner. Tell me your age, and then 17, and then mommy's age.
40.
Now listen, as close as you know.
Wait.
As close as you know. Oh, I think she's 51. It's good enough for government work. Nobody really cares. Also, if I know your mom, first of all, if I know your mom, I'm not going to talk to her about it, so I don't care. Number two, if I know your mom, don't lie to me about her age, because I already know how old she is. What? What do you think?
Are we saying our mom's age right now, or when she had us?
No, right, what is she is right now. Yeah. Ish. You needn't text her. Just guess. I don't care. It's not that big a deal. Like, Mom, what was your exact birthday? No. Okay, what? Hit me.
16
And 38. Oops, that's 32. That'd be a little tricky. Go ahead. One of you guys. I don't care.
17 and 51.
Beautiful.
18 and 48.
Ah, can't type. Somebody.
17 and 51. Same thing.
Wow.
It's got 3 of them.
17, 57.
By the way, when you get to someone like Joe, who's the end of the line, clearly probably going to have an older mother at that point, right? If you're the old last in the line of a bunch of children. Go ahead, Hainsey.
17, 42.
Mm-hmm. Oops. Go ahead.
17, 42.
Hit me.
16, 47. 17, 40.
17, 47. 16, 47.
Okay, so 17,
Mm-hmm.
62.
Listen, that's just how it is. Go ahead.
1848.
Yes?
1846.
1639. 1649. 1754.
What? Same?
1849.
1740.
Ah. Okay.
1844.
That all? That's all of us? All right. So, there is my data. Okay? Now. Okay. I'll give you a few minutes to enter that data in your specific machine. I don't know. I wasn't paying attention to myself. Sorry. Sorry, I was all just excited. Take your time for a second. It's fine. Whether you're using Desmos or whatever, it doesn't matter to me. List 1, list 2, if you're in the calculators, please.
Oh my gosh, I would have known.
Oh, it's so small.
Yeah, it's really hard to track. Okay, I'm trying to remember. Oh my god, I lost where I was. I'm having with Oh my god, I lost my place. I hate you. Is there only 25?
Okay, it's only 25.
There's only
I
25.
don't even know how.
That's 24 actually, right? It's line 25.
I definitely did.
Okay, where? Can you make it bigger?
Wait, are you gonna fit yours? So did I.
I'm not going to include mine. So you want me to scoot it up a little bit and zoom in?
Yes.
No, I'm gonna lose my score.
Where are we at? Okay, I'll shut up. get up and move closer if you need to.
Oh, I'm gonna have to. Oh god.
Get up and move. No. I'm going to complain about it instead. It's easier. I know. You just had the look on your face.
Maybe that's just her face.
Ouch.
Okay, look at this. All of my L1s are
Seriously, you're all... Just get up and move. I'm sorry. The last 6 times we've had a presentation in our after-school meetings, that literally the font's been this big in the Lewitt room.
Huh? You gotta be kidding me. I don't mention number.
See, that's what I'm gonna do.
It's great.
I was gonna
Whole thing.
I like them. They're cute.
They're bifocal.
Nice.
You have bifocal?
Me too. Okay. There's 24 data points, yes? It's line 25, but there's 24 data points because I put titles on top. Yes? Where are we at? Do we have... Where are we at?
No, not 74.
Seriously, instead of just sitting there squinting at it, why don't you get up and move?
I want to be straight up. I just need to like.
I just work here. For now. That's my thing. That's my thing. Got it?
No. So what do you want me to do with the dog?
I want you to sit tight for a minute.
Fiddlesticks. Done. Am I exit out of it?
Yeah, you're already going. Just a minute. From now on, all you do is hit zoom 9.
That's awesome.
Okay.
I'm alive.
Okay.
No.
Okay.
I'm just gonna watch.
Okay. Shh. It's fine. If you didn't get it, you just want to watch. That's totes fine. It's not a listen. It's not a giant number problem there, kid. Just relax. Just play along at home. None of your data. What are you knowing about? I'm just getting up the chart, dog. Just making my chart. Shh. Now, if you were here last week, your 83s and 84s and whatnot are set up for you. You literally have to hit zoom 9 and you're there, right? We had all of our scatter plots set up on our calculators last week. If you simply hit zoom 9, you will see it. It should look something like this. If you did it in Desmos, it's already there, yes? Nice. Okay, now, first of all, okay, at this point, I guess if you're still typing, that's cool. We'll wait for you for a few minutes. But here's the deal. I look at that thing there and I'm like, it does look like it's going up slightly, yes? But it seems like we have a lot more 17-year-olds than we do 18s and 16-year-olds. That's great. Wow, I'm surprised. 17 has a lot more variation. Well, there's more of them. If I talk to more 18-year-olds, would I find the same sort of variation? One would think, okay? But life goes on, okay? Now, we have this situation here, correct? So, can we go? Okay, so I'm going. I don't care. Screw you, I don't care. Here we go. Now, here's the game. Here's the game, friends. We are going to perform the test to see if it is significant or not before we go any further. So the test, of course, requires us to find R and, of course, R squared. Okay? So let's go over how we do that. If you are on a calculator, a TI-83 calculator, listen carefully. You will go to Stats, Tests, right? And then Linear Regression T-Test. Do you see that? Go there now. Yes? And it asks for list 1 and list 2 and all this foolishness, does it not? And it's already in there because we already did it last time, did we not? Here, let me open mine up and I'll even show you. Mine will be different than yours because it's old wheat, and I'm not going to waste time typing this into 22 different types. Not important to me, don't care. But if I did this, give it to me. So stats, stats, tests, linear regression, t-test, right there. Boom, 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 boom. Remember last week we put this regression equation in y1. So that's Q, and then you simply hit calculate down here. I will tell you some other time, not right at the moment. Sit still for a second, we'll get on that. Now, notice that you get a t value of 1.52. 83, 84 users, you see that?
Maybe I had it wrong. Keep going.
And you get a p, oh, this is last week's. This is not yours, okay? I'm saying, okay, I'm sorry, thank you. Again, this is last week's data. So, you get a t value here. And you also get a p value. Write that down, or keep it in front of you. For the rest of us, we're going to go find our correlation. Notice our correlation is going to be down here at the bottom of this for you people. But listen, you don't really have to do this because you guys, 83, 84 people, already have your t value, don't you? Now, for the rest of us, we're going to go, if I have Google Sheets or if I have Excel, I'm going to do equals coral, right? And it wants y's first and then x's. Yes. Boom. Boom. By the way, I was reading a comment the other day. It was pretty funny. It's a person around this area. So this guy that I know owns a shop, and apparently he has a Facebook page for his shop now, which is interesting. So I was like looking on the comments, and of course there's the random idiots and stuff. He does a... God, I can't remember. It's instead of awesome. God, what's the word that starts with it? Sounds like awe. Honest. No, that's what it was. Honest. AWE space NEST. And I looked at that and I'm like, no, really? Really? Moron. All right. So, equals correlation. Is that what you got? 0.15. Is that what you got? Nice. By the way, that's a lousy correlation, just saying. It's a lousy correlation. Watch me do the following. Suppose I take that guy there and square it. Oops. That's R. So there's my R squared. All right? If I'm on Google Sheets, that's the way to go. If I'm on Excel, that's the way to go. It's the same number that everybody else got. Am I right? Bam. Now, if I'm on this computer and I want to find this thing, well, I'm going to write it down. So T is equal to, what was my R? 0.15 or something? 0.15? Square root of 22. Where did that come from? Why is it 22 though? Because I had 24 pairs of data. Over 1 minus R squared, which is what, 0.02 or something? 0.02? For God's sakes, I have to do everything around here. 0.024. Because I squared it, yo. R. I took R and I squared it and got R squared. Nice. Nice. So, crunch that number out. Let me get my calculator here. So, I'm just going to do it myself. So, 0.15 square root, wherever that freaking thing went. There he is. 22 divided by parentheses. Don't screw that up. Literally, don't screw that up. 1 minus 0.024. Oops. Then actually close. Yes, there, attaboy. One more time. Oh, I get a T of 0.7. Is that what you guys got? Wow, how about that? Nice. Nice. Now, without even looking up a critical value, because I can and I will. But listen, friends, here's my T distribution. You know, zeros here, whatevs. You know it's going to be somewhere around plus or minus 2, right? Where the critical value happens, right? Right? It's always around there. I'm in here. What does that say? I'm going to fail to reject. And by failing to reject, what am I saying? I'm saying that. What does that mean? That means there's no significant relationship between the x's and the y's. Does that make sense? So I'll go ahead and find it in a minute, Joes. Fail to reject H naught, which means there is no significant difference. There's no significant relationship, rather, between x and y. And so because of that, what do? Stop! Don't predict anything. It would be stupid to predict from that. Stop. I mean, you can make an equation, right? You can get y equals mx plus b for it, but there's no relationship, so Yeah, it'd be just at best a kind of a crapshoot. Okay. Now, let's go ahead and find this p-value just for a good time, shall we? Okay. So people on your Google Sheets, for instance, you Google Sheet types will want to do this or whatever. So t-dist, and we're going to go 0.7, comma 22 degrees of freedom, comma 1, I think, or maybe not, comma 1. No. What does it say? Oh, I'm sorry. Thank you. So, okay. So let's say that's Excel, right? And because it's right now, because this is Excel's version of it, whatever I get, because it's upper tail, I times it by 2, right? All right. What is it on Google Sheets? It's t.dist, and then what does it want to know? 0.7.
The degrees of freedom and then how many tails?
2 tails tests, right? 2 tail. What does it come out to be? I just work here. Somebody tell me.
0.49.
0.49. Is that what we got? Does everyone agree on 0.49? Does everyone? Yes. Okay, I heard everyone. There we go.
And you don't have to do the
That's already
1 minus.
You don't need to on the Google Sheets because that's how it's set up, which is weird. But again, know your machine. I'm not real fluent in Google Sheets on that because if I have a choice, I'm going to use an Excel or I'm going to use my calculators.
So
Okay?
this is the prediction.
So no. This is our p-value. Another way of saying what? It's another way of doing this thing right here. I never did actually find the cutoff score, did I? But I could have if I wanted to. And again, it would have been out around 2-ish, yes? Right? 2-ish. It's always around 2-ish. 2.3, 2.1, 2.0 is 2-ish. Okay? And so 0.7, geez, that happens all the time. Literally 49% chance that it happened if there was no correlation. Literally. Yes?
These problems are always 2 tails.
Always. Why, by the way? Because R could be plus or minus. Yes? Could have gone either way. Now, play along with me humor me for just a moment, please. Just a moment, if you would, please. Okay, thanks. Now, go back over to your graph here. Now, if you did it in your Desmos, you already have the equation, right? It already told you y equals, yes? If you did it on a calculator, that t-test business, it already told you y equals ax plus b or whatever, right? Pay attention, because I think it's a plus bx in that deal, isn't it? Hannah? Is it a plus bx in that? Yes, so pay attention to that, okay? Don't screw it up, okay? It's very easy, but people screw it up because they aren't paying attention. They're like, Mr. Groomer, you always say a plus bx. Well, I do, or ax plus b, and I do, but just be aware of that. Now, I'm going to show you, oops, no, I'm not. Maybe I am. I'm going to go ahead and just pop this equation out just for a good time. This equation should match yours pretty closely. Oops, there it is. Did you get that? Something like 1.35x plus 24. Okay? Okay, hang on. One thing at a time. Okay, so Excel people, you just right-click. That pops that up there for you. Mr. Green, is there another way to do it? Yes, I'm going to show it to you in a second. So you guys on the Desmos feel really comfortable about that. 89s, you feel good? 83, 84 people, you feel pretty good because it told you in the t-test. It literally tells you in the t-test what it is. Okay? It did. Did you do the t-test? Did you push the buttons for t-test like I told you? Okay, well, it won't be wrong on the next one. Just play along with me for right now. I can't fix what you messed up on the entry. I can't do that. Now, okay, so people on Google Sheets. Then what you can do is this. It's been a while since I've done it this way. Yes, slope. Oops, that's slope. Right. This is. I know I'm in Excel, but it should work exactly the same way for Google Sheets. Yes? Try it with me. Does it? Okay. So it wants the known y's first. So I click and drag my y values, comma, my x's. Okay? There it is. It's the same number. No one's terribly shocked by this. Right? By the way, there's literally 17 million ways to do these problems. I'm showing you what I think are maybe the easier ways. Later this week when we go to the lab in multiple linear regression, when we get to doing that and everybody's in Excel or Google Sheets, because we can do it that way too. It's very straightforward and very cool, but not everybody has that today, so I want you to have what you're comfortable with for single variables. Not important. Now, equals, how about we do intercept? Because that's what it's called, right? intercept of the known y's. Oops, try again, dummy. The known y's, comma, the known did I hit comma? I did. Comma, the known x's. What? There it is. Y equals ax plus b, ax plus whatever you want to call it. Now, as I said, you'd be dumb to try to predict from this, right? Because it's a bad correlation. But we can still find those pieces and parts.
Wait, Google Sheets
Here's what?
Google Sheets only gives you the slope. Like, how do you get the?
It doesn't give you intercept? Oh, for God's sakes. Oh, no, not really. For real? God dang it. All right, I'll figure that out in a minute, and I'll tell you
wait, no,
Google
never
people.
mind, I found it.
Thank you. What'd you do? It's just intercept?
Yeah, you just type intercept.
That's what I thought. Okay. Good. Nice. Okay, now back to my equation. Let's look at this equation just a skosh more, shall we, friends? This is 1.34, basically 1.35. What is that saying? It is saying that your mother is getting 1.35 years older for every year you increase in age. Mr. Groom, that's weird. Well, it's weird because it should be 1 to 1, yes? As I said, from years to years to years, I've had this picture show up very similar to the one up above. I've had it show up where literally the 16-year-olds all had higher moms than the other ones. Meaning as you get older, your moms are getting younger. Well, again, it depends on the sample you take it from. Mr. Grimm, have you ever had it where it was almost 1 to 1? Yes. And it creeps me out when it comes out perfect like that. Okay? But it happens sometimes. Also, notice, this 24-bit, what is that about? That's when you started having children, because that's when your age was what? 0. Which is when, yeah, exactly. Now, it's not perfect. It will never be perfect because we have the youngest children in the crew, and we have the oldest children in the crew, and we have a whole mix in between. We got people that started late, started early, did it again, who knows, whatever. And so it's never going to be perfect. If it was, it would be literally 1x plus whatever. Okay? But it's never going to be that. But that's okay. Now, what I want you to see is this. This intercept means something. The slope always means something. Remember? What is slope? By definition, slope is, don't say rise over run, because that's true, but that's not what I want you to say. What does slope mean? Where did my pen go? Oh, here it is. What does slope mean? Rise over run, of course. Why did I put a Y on the top?
Could you go wide?
I know! First year teaching, I thought I had fixed the world. Nope, they built a better idiot. They spell it with a Y on top, they still put the X's on top in Algebra 1. I thought that would solve all the problems of the world. It did not. And then Patterson goes, why do all the kids from your class spell it with a Y? And I told him, like, that's pretty cute, but they still screw it up. I know. Nobody taught that. That's a J. Groom special.
I thought you misspelled it. I was like,
That's a J. Groom special right there. But it didn't do any good. Listen, friends, it is the change in Y over the change in X. But specifically, if the correlation is significant, then what we're saying is it is a change in Y that is caused by a change in X. But if it's not significant, then it's just kind of all random and weird. Things happen. People are weirdos. So on this last one, we had lousy correlation. So I can honestly say that, no, I don't think it's not significant. So any change I see is just natural variation of people. People do their thing. Okay? That's how it goes. That's how it goes. And we don't cry and whine about it. We just deal with life and move on. Okay? Some people get so excited about, I want it to be significant. Why do you care? Why are you so weird? Nobody cares. Okay? Now, here is some new data. I'm only going to put about 12 into this one. So, for God's sakes, get it right this time. So, distance between eyes and weight. First thought, we're like, that feels like a weird thing to do, Mr. Groom, but I'm going with it. 1 centimeter, 2 centimeter, 2 centimeter, 2 centimeter, 3, 4, 4. Oh my God, there's all of 10 of them. All right. 234, 210. Apparently, we're trying to find out if the distance between men's eyes had any correlation with their weight. Let's find out. I don't know. So I took a sample, of course, randomly selected sample. God forbid I would not do anything random. It's completely random in order of which it came out back here. There it goes. Okay? Now again, just some data. Okay? If this were true, it would help me to hire appropriate people. All right, I don't know, whatever. Maybe it would help me to find whatever it is. I would maybe use this for something. I don't think I care how wide people's eyes are apart, but if I did, I might be able to help do something with it. Oh. What's that?
Did you do the coral thing?
I haven't done correlation yet. You want me to? I will. No, shrink. Okay, one thing at a time, peeps. It's okay. There we go. Okay, so there it is. First things first. Does it look linear? Yeah, very. Very linear. So let's find a correlation, shall we? So do you do it the way that you were told to do it on your machine? And then we'll talk about it in a minute. Holy cow, it's negative. Well, duh, it's negative because it's got a negative slope, yes? Hey, it's pretty close to 1. Well, I hope so because it's almost perfectly linear. Yes? Do you agree with me this time, Abs?
Yeah.
Yes. All right, Abs. If I wanted r squared, I'm just going to square, the r. Not very difficult. Okay? And again, those of us with Desmos already have that, yes? Those of us with other calculators already have all that foolishness. And those of us with T83, 84s already know our T and our P values, don't we? But for those of us that don't have that, we have to do like an extra step or 3. It's no big deal. Okay? Got it?
No.
Okay, keep trying.
Well, 89, so 3 and 4, like this step.
Okay, tell you what. Why don't you come over and sit by Ziegler? Ziegler, are you not using your 89? Oh, for God's sakes. What's the matter? What now? Where are we at?
Looks like you're like,
Yeah, you don't. Why are you using green for? Is that where your data is?
You get negative?
I mean, I can So look, yours doesn't. Look, your T is not a T value. You see that? There's no T. It has a confidence interval. You see that? Notice what it's on that confidence interval. 0 is on that confidence interval. What does that mean? It means that it is very significant. If 0 is in your confidence interval, you fail to read that. All right. I'm about to tear my hair out doing it 22 different ways. All right. That's the funniest thing. I'm done. That's it. I quit. It's not going to get any funnier today. That's it. I quit teaching. That's it. That's the highlight of my day right there.
I'm really sorry. I wasn't trying to be rude.
No, it was funny. It actually made me laugh.
It actually.
Not like Saturday when some dingbat came into my class and she goes, "You're bald." Well, I ignored her. And she said it again, so I ignored her again. And this other guy goes, "God, maybe you make a bigger deal about it." I'm like, "Thank you." Exactly. So R times square root. How many pairs of data did we have? 10 minus 2 is 8 divided by parentheses 1 minus r squared. What? And this should be our t value. Negative 7.35. Yes, 83, 84 people. The magic button gives you everything you need.
Okay.
I know. So does the 89. That's okay. We have to do a little extra step. Woo, whoop-de-dip. Now, holy crap, look at that. You got a t-value of negative 7.35. That's cray-cray because why? We know that the cutoff is always somewhere around 2-ish. You're out here. You are way out in Freakville. So what does that mean? It is reject H naught. By the way, I did it right H naught because I was ahead of myself. Rho equals 0, rho naught equals 0. So therefore, whoosh, therefore there is a significant correlation. Okay? Okay. Now, what? And it's 10.1 and yeah, it's mostly 10.1. Okay, mostly. Yes. What?
Homework sheet? Or do you
In a minute, can I just finish what I'm doing? Thanks. Okay. Shh, 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 shh. Now let's just go ahead and look at that p-value just for a good time, because, okay, because I want you to be able to see that, because keep in mind that that what do we have? 8 degrees of freedom and 1. No, not 1. What do you do? 8 degrees of freedom times 2. That's what it should be on your TI 8384s. Okay, do it on your machine. What did you guys say it would be? You had it already. What did you get for a p-value? It's 0.00 something or another. What? I don't know. Punch it out. Let me see. Just hit the magic button again. Just hit the magic button again. What? What? 4 zeros. 4 zeros. And then 7, 8, 9? 7, 9. That's their p-value. That's what the p-value should be. In other words, that's really small, Mr. Groom. And therefore, again, totally significant. When we go to the lab and we're using Excel, it will always just be the p-value we're looking at. So I want you to feel comfortable just looking at this guy right here. Hey, 0.05. Hey, this is less than 0.05. It's highly significant. Let's go. Okay? Just boom, 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 to the point. Okay? Now, all right. Whew. Now let's find our equation. Again, if you're in Excel, literally just right-click on one of the points, add a trend line. It's linear. Boom, boom. You're done. And so that should be your equation. If you are in Google Sheets, equals slope equals intercept. Whatever. And if you're in 8384, you've been done with this for half an hour already. So what was the equation? Y equals, what was it, Connor? Do you have it? Somebody that has it, like literally already done? We had it there about 5 minutes ago or something. Oh, Naomi's on it. No, not that one, the new one. What'd you get?
Wait, do you want it the way you say or the way that mine?
I don't care. Just spit it out for me, dear.
230.7.
230.7 plus, minus?
Minus 8.94.
8.94x. But Mr. Groom, mine said negative 8.794x plus that. It's the same. Nobody cares. Just don't screw it up. Okay? Now, what if my eyeballs were literally sitting on top of each other like this? Perp. How much should I weigh if that were true? They're like right here. No distance between them. How much should I weigh? It's literally on the board. That's why I'm asking. 230.7 degrees. Yes? Degrees. Did I say degrees?
Yes.
Pounds.
Okay.
Now, as they start moving this way, what happens to my weight?
You go down.
It goes down. And so if they were like 5 centimeters apart, how much should I weigh? Do not look at this. Do not look at this. Yes, it'll be somewhere near here. But if I want to know about 5, I will literally just plug it in. Yes? So I will just go equals 230.7 minus 8.94 times, what did I say, 5?
Yeah.
Boom. If I was on my TI 8384, and if I have stored my regression equation in Y1, then a cool way to do that saves a little time is to turn on, you piece of crap, is to go vars, y vars function. You see that?
Yeah.
And hit Y1,
Yeah.
and then of 5. Shut up! Of course, mine's different because this is last times or 3 times ago's information. Nice! So it literally sticks 5 into that equation. That's cool if you have it. If you don't, just boom. Okay, what?
So I noticed
Legal mess.
when we were about to
Shh, then don't worry about it. What?
wouldn't it be y
Yes?
equals like mx plus b?
Oh, that's literally what I said. If you're a weirdo, you are literally okay to write it this way. Negative 8.94x plus 230.7 because addition is commutative. Not communicable, commutative. Yeah, this girl one time in we were reviewing commutative property and stuff and all this stuff in Algebra 1. And I said, because addition is communicable. And I went, no, that'd be herpes. All right, no, ridiculous. Okay? So the point is, it's commutative. You can write it either way you want to, but pay attention to which is which. For every centimeter my eyeballs get apart, how much lighter do I weigh? 8.94 pounds. Shut up. For every inch they get apart, I go down almost 9 pounds in weight. Okay? Hey, shh, this is fabulous. Now, Fiona brings up an interesting predicament. Mr. Groom, what if your eyes were like 6 inches apart? That's great. That's like 15 centimeters. Now, can I predict for this? Yes. Is it going to be a good prediction? Why not? Because of I'm going to say this, and some clown is going to tell me it's not a 4-letter word. Because of the 4-letter word called extrapolation. Extrapolation is a bad word, just like all the other 4-letter words. Okay? Although I know it's like 12. It's still a bad thing to do. Now, a person could literally type it in. Heck, I'll use Anna's version. Negative 8.94 times 15 plus 230.7. Oh, I'm emaciated. Well, my head, I probably have bigger fish to fry. My eyes are over here. I also weigh 96 pounds. But that's ludicrous because my data is nowhere near 15. Okay? Now, you want to pay attention to this next set of instructions I'm going to give you. Now, in 10.1, you will find that the homework problems for 10.1 are the same homework problems for 10.2. At least they used to be. Yes, they still are. They are. It freaks me out because they look different because they're like on the page in different orders. But they're the same. Why would they do that? Because the directions in 10.1 say test if there's a correlation or not. So this is what I want you to do. On your homework for 10.1, I want you to, for God's sakes, I can't find my pen. Number 11, H naught, H1, rho equals, rho not equals, whatever. Here's my graph, whatever. Oh, look, R is 0.12, R squared is 0.0144, whatever. Hey, T is equal to basically 0.2 or something stupid. Oh, look, I got a p-value of 0.53 or something stupid. That's exciting. And then, so what is my decision? Fail to reject H naught. And then what should I do? Stop! That's it. Now, am I done with problem 11? Yes. So draw a line right underneath of it. You see this? Oh, here's problem 12. H naught, H1, rho equals, rho not equals, whatever. Jiminy Christmas, that's almost perfectly linear. What do you know? I know, right? 0.91. R squared, 0.83 or something, whatever. I'm just making this crap up as I go. T equals 3.97. What? That's a p-value of 0.002 or something. I'm making this up, so don't quote me on those numbers. Okay. Hey, what does that mean? Reject H naught. So what? So what does that mean? There is a significant relationship, which means I should be able to do what? Then leave room. Because in 10.2, they want to know what is y equals mx plus b. You with me on this? Okay. and then they're going to ask you to predict. But leave room. How much room do I need? Well, if you're a person who has, 17, like a 22 font, quite a bit of room. If you don't have a very big font handwriting, then not so much room. Okay? The whole point is this, is that most people have a hard time learning all this crap in one day. And especially since we have about 87,000 different pieces of technology, none of which I care which one you use. But so we spend a day finding how to do this, a day finding So tomorrow, we're actually going to spend a lot more time getting into this equation. And we'll actually write it as y hat is ax plus b. Y hat. These are the predicted values. And we'll spend a little more time tomorrow doing some predictions. So you should get a little bit of time to work tomorrow too. That's right. I'll bring one. Let me come get you. Can I get you a cup of coffee too or anything? Maybe a donut? Oh, do you want to? No, ain't gonna happen. You give what you give, girl. All right. It's also online. No, it's not. I lied. I thought about this weekend, but I didn't have it at home, so I said I have to.